Okay, there we go. I think I'm recording now. Okay. So oh, there's the screen I'm looking for. There's the chat screen. Okay. Okay, so let's start with this. Let's go back to this then. So we have the average weight of 14-year-old boys is 17. This should be weight. Well, I can just change it to weight. With a standard deviation of 30. So if a sample of 16 boys is selected, what's the probability that their average weight will be less than 175? So the average weight of all 16 boys will be less than 175. And the way to compute the answer is you take Z score is equal to 175, and that's the number that you're interested in finding the limit of. So 175 is the limit for this particular problem. 175 minus the mean, 170. That's always, this 170 always goes here. This mean always goes here. Can you see my screen?
Yes.
Okay. Divided by the standard deviation, which is 30. That's also given. Divided by the square root of the number of people in the study, 16 in this case. So you compute this number and be very careful how you compute this number so it turns out to be right. Make sure you do this correctly on your calculator. Get 0.67. Now we just look in the table, in our Z table for 0.67. And in this case, we are doing less than. And Andrea, this is the part you were asking about. The table gives you the percent less than the Z value. So if you go look up 0.67 in the table for the Z value, you will get 0.7486. And the conclusion then is that 75%, there's a 75% chance, 75% probability chance that the average weight is less than 175.
Oh, it would be if it asked what's the probability the average weight is is greater than 175, would the answer on the Z table be subtracted from 1?
I would take 74, I would do 1 minus 0.74886.
Okay.
And that's exactly what the next problem is.
I wish I knew that yesterday. I'm so mad. Oh my gosh.
Well, let's not get mad. Let's fix it. Okay. I mean, seriously. I mean, we'll talk Friday and see what we can get done here.
Okay. Thank you.
No problem. Okay. Now, Lauren, was that you asking me about how to solve problems? Is this helping you with the format?
Yeah, it's what I'm looking for, but I just still feel really confused when presented with a problem on the quiz. Sorry, my kid is crying.
Yeah.
I'm going to mute real quick.
I'm sorry, but your kid is crying too. I understand that totally, believe me. Well, in order to solve the problems on the quizzes, like I said, they have lots of words in them. But the way to do that, in my mind anyway, is to, when you read a sentence, if it's got some data in it, like the average weight of all 14-year-old boys is 170, well, stop right there and say, okay, what does that mean to me? That says that mu, for this population, mu equals 170. and write that down as an equation. You write down mu equals 170. And so you don't keep going. Just stop and write it down. And come back and start the sentence over. Average weight of all 14-year-old boys is 170. Okay, I got that. With a standard deviation of 30. Well, then you write down sigma is 30. And I think you can get through the problems like that with that technique, I guess is the word I want to use. And like I said, there's going to be a lot more words in it. They'll give you some Latin words probably, and that kind of stuff.
I have a question.
Yes.
Where did that go? Where did the square, does that say square root of 16?
Yes, that's square root of 16, which is 4.
I'm not familiar with that step.
With this equation?
Wait, yeah, what was the formula for that?
Let me go back and see if I have it written out in any way. Yeah, there's one. No, these two are the main formulas that you need. This one that I just highlighted, and this one down here.
And how do I know which one to use?
Well, it turns out it doesn't matter which one you use, as long as if you use this bottom one, you're always it'll always work. If you look at them, the difference is that the top one is when you have a single person in the sample, a single person. The bottom one is when you have n people in the sample. So in our case, we had n was 16, so we had the square root of 16 here.
Okay. Thank you.
Does that help?
Yes, thanks.
Okay. Good. Let's go back to solving a problem then. Okay, oh shoot. Let me do this. I can't write on it like this, but that's okay. So we're now looking to solve this bottom problem where we have the same 14-year-old boys, and we only have a sample of 9 this time, and we're asking. So you see, when I read this, I would say if a sample of 9, n is 9. 14-year-old boys is selected. What is the probability that their average weight will be greater than 160? So I know I'm interested in 160 as this value that is, I don't know what to call it, to tell you the truth, a limiting value. But it's just what the value that they're interested in. And so that value, again, the way to do this is to compute a z-score down here. And you take the 160, it always comes first, minus the mean, which is 170, which is given up here for us, 170, divided by the standard deviation, 30 over square root of the sample size, 9. You compute that and you get minus 1.0. And so now we're looking for the probability that the x bar, the average weight of the 9 boys, is greater than 160. And I've written this out as so the z-score is minus 1.0. I find the z-score of, and if you go look that up in the table, you take 1.0, look it up in the table, and you get 0.1587. And since you're doing greater than, you do 1 minus that.
Professor, can you just clarify, after you compute the z and you get the negative 10, what is the 30 over 3? What is that? What are those numbers?
The 30 comes from here.
Oh, okay.
And the square root of 9 is 3.
Oh, got it. Okay. So, okay. Thank you.
Then that becomes 30 over, or minus 30 over 30. Well, that works out. Minus 10 over 10. Minus 1.
Okay.
Okay. So then we get minus 1 for the z score. I look up in the table the z value, 8412. No, 15887. 1587. Then I subtract that from 1, since I'm doing the greater than.
So if it came out to like a 1.4, would you have to go over on the z table?
You mean if the z score came out to be minus 1.4?
Yeah. Would you then go? Okay.
Yeah, so you would go over to the minus 1.4 and it would be 0.80 or something like that. I don't know.
Okay.
Yes, you would have to, yes, you need to get to the second decimal place, which is the top row.
Okay. And then if you're looking in the z table and the number that you find closest to whatever you're looking closest for, if it was, say, like a 1.0 and then you found the number under 0.04, you just add that, right, to the z, making it a 1.4.
Yes. No,
Okay.
you would get 1.04.
1.0. Okay, I think I messed up there. So say it was like a negative 0.6 and you needed to add a 0.09. What would that come out to?
So you need to, so if your z-score, let's do this a little, if your z-score happened to be minus 0.69, 0.69. Let's say it turned out to be that. You see where I wrote that now?
Yes.
Okay. If that turned out to be minus 0.669, then we go look in the table. And you find this minus 0.6. The table's not there. It's not here. Go find the table. Yes, here we go. Where we go? 685. Critical values. Okay, so minus 0.69, minus 0.69. So I find the minus 0.6, and I go all the way over to to the 9 column, and I would get that 2451.
Okay, yes, I see that.
Okay.
I was confused about how to, I think I did something odd, which I shouldn't have because it's so simple, but thank you for clarifying.
No, that's no problem. And, you know. Okay, so here is another problem, evidently. And this one involved, okay, these two involved means, the average weight. And this one involves a percent of people. And so instead of asking what's the average weight of a sample, I might say, what percent of the sample have a certain property? So for example, 30% of all 60-year-old men have a BMI greater than 43. Made up numbers, so whatever. So 30% of all 60-year-old men. So that says that the population proportion is 30%. And so you would write, like I did down here, immediately you could write this, P is 0.03. 0.3 rather. 0.3, where P is the population proportion. Now, when I take my sample of 10, what's the probability that I'll have 35% of the men will have a BMI greater than 43? So what I'm asking, I mean, On average, 30% have a BMI greater than 43. What I'm asking now is what's the probability I'll get 35% will have a BMI greater than 43? And the reason you might ask this is that if you say the national average of BMI, suppose I go to a particular area, I will pick something that I know is bad because I've been there. West Virginia. And I look at the BMI of West Virginia. And I find that the BMI is much greater than 43. Much greater than 43.
Sorry, there's somebody's microphone that's like, I can't hear the professor.
Someone's microphone is on with a very loud background. I can't hear anything.
Okay.
Can we all mute our mics real quick?
Except me. Okay. Okay. Thank you for doing that. So let me start over. We have 30% of 60-year-old men have a BMI greater than 43. So the population is 30% of 60-year-old men have a BMI greater than that number, made up number. So the first thing I would write down is that my population proportion is 0.3. P equals 0.3. And now my question is, if a sample of 10, well, look, now N is 10. And I didn't write that down here, but it's going to show up real soon. N is 10, 60-year-old men is randomly selected. What's the probability that 35%, that fewer than 35% of the men will have a BMI greater than 43? So on average, 30% have, but if I go to, but now I take a particular sample, what's the average, what's the probability that their average will be, that 35% will have a BMI greater than 43? Got the problem? Does this make sense? Well, you can't talk to me because your microphones are off, sorry. Okay, so the way to work this problem is that you set a p hat. That's just a nomenclature that has been used in statistics for quite some time, equal to this 43 sample proportion. Oh, p hat is the sample proportion of men whose BMI is greater than 43. This is the average amount that this group will have. Now my question, and then I have to calculate my standard deviation. And the standard deviation when you're doing proportions is the square root of p, which was 0.3, the population proportion, times 1 minus p divided by n, which was 10. So you throw those numbers in, have 0.3, 1 minus 0.3 is 0.7, divided by 10, and I take that number, multiply, divide, take the square root, and I get 0.021. And again, I compute a z-score. My z-score this time is p hat minus p divided by the square root of, divided by the standard deviation, which was 0.221. Now this shows 34. That probably should have been 35, okay? I don't know if that's going to turn out to be exactly 1.9 now, but we'll say it is. So the probability that p hat is less than 0.35 is the probability that z is less than my 1.9. And I look it up in the table, I find that's 97%.
So you only I'm sorry. So you only calculate the 1.90. That's the only one you're looking for?
No, I look up 1.90.
Oh, okay.
Yeah, so that's on the table. You look up positive 1.9.
Right.
And then you go, and it's only to 0, so we don't have to go over any. It's 9713. Oh, good. Right. And that's the answer then. So you have a 97% chance that
And what about the 35? 0.35?
The 0.35, okay, so the summary here is that, let me write this down, maybe that'll help. There is a 97% chance that that see what is the probability? That at most 35% of the men, yeah, at most 35% of the men will have a BMI greater than 43. So I changed, okay. So I changed, this is the key phrase here. There's a 97% probability that the percent, let me say this, that the percent of men in the sample the 97% chance that the percent of men in the sample with BMIs less than 43, yeah, less than 43 is there's an average, there's a 97% chance that 35%, or maybe I could say then that 35%, that 35%, I'm just trying to find the best way to write this, 35% of the men in the sample will have BMIs how's that sound? There's a 97% chance that 35% of the men in the sample, 35% or fewer of the men in the sample will have BMIs less than 43. Is that confusing? Let me say this then. Nobody.
Yes, it's confusing. Sorry.
Okay, I'm going to let pick a letter, somebody quick. Pick a letter.
X.
X. I'm going to let X be the percent of men in the sample with BMIs less than 43. Okay? So I have my sample. In this case, there's only 10. And I'm letting X be the percent of men in the sample who have BMIs less than 43. So if I have 2 people with BMIs less than 43, then X is 20%. If I have 8 people with BMIs less than 43, then X is 80%. Okay? What I'm trying to say in the next line is that there's an 87% chance that X is less than 35%. That's a lot to swallow, I think. So you have to talk to tell me where you are so I can continue to explain, or I don't know where to go if you don't help me.
What is sig p?
Sig p acts as the standard deviation. Remember back here in this equation we had, somewhere back here. No,
Slide 18.
slide 18. How do you know that? But you're right, huh?
19, sorry.
19, right. Remember in this equation we have x minus mu over standard deviation?
Yep.
Well, this is when we're using means.
Mm-hmm.
When we're using proportion, we have to replace this standard deviation with this with that sig hat.
Professor, is there a secondary formula for that replacement?
Another one written down somewhere. Yeah, I'm sure there is.
And we're supposed to find that to answer that question? Is that what we have to do?
Yeah, I'll find it for you.
I mean, for me, I just love it when all of the equations are, they're like God, kind of these equations, right? I don't even know how people came up with them. They're eloquent and they work. For me, it works when I'm working on these problems to say, okay, this is the universe of equations that are out there. And then I can then say, okay, which one am I going to use? But if there's a little bit of a caveat on that equation, it would be helpful to have that.
Well, I'm looking for an equation that is, okay, this is,
If it's in the book or if it's in your notes, then
no, I'm going to take, I was just looking to see if it was written out, and I can't write an equation on this computer for some reason. It took my capability away from that. Just give me a second here, okay? Where it looks like we're getting there, maybe. All right, I'll just write the equation out up here. Let's go to slide 18.
If you could repost the updated slides, that would be helpful. But if it's in the book, sometimes it's good to bounce off you in the book, because sometimes the book,
No, it's definitely better. Yeah, sure. No, let me just, I will just write here. Z is equal to P hat minus P divided by what I'm calling sig P. Okay, and I'll tell you what all these things are.
Can I ask a stupid question?
There's no stupid questions here, believe me.
Is this Z the same Z that we've been dealing with?
Yes, it's the Z score.
Okay, I haven't actually done this module yet, so I'm coming in a little blind. But I know that, Z, we had a pretty simple thing to do with it for normal distributions. So now we're just doing more with Z. I knew that was
It's just, a lot of, that's why we studied the normal distribution, because that's all Z's, and Z pops up everywhere.
Okay.
Distribution is amazingly powerful.
I have a question about there was one question that I was so stuck on, and I could not get it right. I really was so struggling with it. It was about, you have a certain number of students who are male and do sports, and they were overlapping. And then a certain number of students who do sports but who aren't male. And there was one question on the exam where you asked, okay, what's the proportion of students who are male who do sports and who are not male and don't do sports?
I remember the question. I mean, right. I don't. So you want me to find that question and do that one? Is that your question?
That was awful because I was so stuck on it. I could not. I tried to, okay, well, 45 are female, 45 are male, then 55 must be female, but I couldn't translate it into.
Erica, if you post the question on the forum, I understood that chapter pretty well, and I'd be happy to help you. I've been helping a couple other students solve those problems. So if you posted it on the forum, I'd be happy to answer it there.
Also, I asked the same question to Professor. I emailed him, and I could just copy and paste to you real quick in the chat box what he sent to me.
Oh,
I know something really simple that I'm overlooking. It just,
No, I was confused too, so I'll find it for you real quick.
Thank you.
So meanwhile, I've written down the formula that you need here.
Okay, thank you.
I think that's everything you need.
Will you upload the slides? Because I'm going to work on these chapters, over the next couple days. So it'd be nice to have.
Yes, I will upload this, but I've got to go back and clean that up a little bit. This will probably be the only new thing that I have in it. Maybe I'll find a better one of these, but I'll get it done tonight. Upload new slides. Okay.
Thank you very much.
Upload new slides for chapter. This is 13, right? Yeah.
Oh, and one more question. The last discussion we had, I've noticed the grades haven't come out for on the water. Is that just me, or?
I have left that up to the coach to tell you the
Okay.
So I don't know what she's done. Is the discussion closed?
Discussions closed, and normally the grades are posted, pretty quickly, a couple days after the closing. But I've noticed that this one was due over a week ago, and my grades aren't showing that it's completed. So I, started to get a little worried. Okay, did it go through, or
Okay. All right. I will write Sue also. Dr. Static. And see what the status of the discussion questions are. Okay?
Thank you.
No problem.
Thank you.
I'll do that tonight. She's back east, so don't expect an answer today. And I'll upload the slides. I'll write that on my list. Oh, that's up. That's there. Okay, good. Okay, so we never got to do much. We didn't do much today. Well, we did some. What else do we have to do here? So you guys want to talk for a couple more minutes or not?
I'm here and I'll still listen.
I can only stay for a few more minutes, but I'd like to continue.
Okay, well, we'll do it fast then. So slide 21 and 22 are, so slide one, suppose the distribution of weights of a certain type of mouse is in 25 grams and 4 grams. Mean is 25 and standard deviation is 4. And let X be the weight of a randomly drawn mouse from the population. What's the probability that X is between 22 and 29? So that question is, what's the probability that the single mouse weighs between 22 and 29 grams? The next question is, with a sample size of 9, what's the probability that the average weight is between 22 and 29? The average weight of the 9 people. And so this one, so if you can go through these two slides, the arithmetic is, the process is exactly the same. The difference is between n equal 1 and n equal 9. So here you have the square root of 9 for this particular answer, and that's going to change your z-score number, this number, from the previous one. So when n is 1, there's a 61% chance the weight's between 22 and 29. When n is 9, there's a 99% chance that the average weight is between 22 and 29. So that's the point of all of this, is that your bigger sample size decreases the variation you're going to get. With a single mouse, I've only got a 61% chance that he's between 22 and 29. But with 9 mice, I've decreased the variation. The average will decrease the variation. And so now I have a 99% chance that that the average weight's between 22 and 29. So these are two nice slides to go through. Okay. All right, then that's the proportion. So I'll upload that equation. I'm going to find that equation, a better one written out for us. Okay. Any more questions, or do we want to stop for the day? Nobody's there.
Professor, I had a question. I wanted to know if I could talk to you right after class whenever everyone's done.
After everyone's done, you want to have a one-on-one. That's fine.
Yeah.
Okay.
Thanks.
Okay, well, who else is left here?
Hi, I just wanted to remind you, you told me to remind you at the beginning of the class to turn the review on for the last 4 quizzes.
Review on for the last 4 quizzes. Thank you. That's a very good reminder, because that was not on my list yet.
Thank you.
Okay. Turn review on.
And so just to confirm, our final midterm will be the last chapters, 13 to 17?
Yes. And it's only going to be part of 17 now. I have to, tomorrow I'm going to reduce what we're supposed to do and get new dates and that kind of stuff.
Okay, so that's kind of far out. That's a couple weeks away. So for now, just, continue on with 13, 14.
Right, continue on with 13 and 14 the way you're doing it.
Okay,
Right.
all right, thank you.
Okay, so let me see if I can figure out who's left here. I think that might be the only. Erica, are you here?
Yeah,
You were the one that wanted to talk?
no, I think there was another
Person.
student.
Another student.
If you guys wanted to be private, I could go. I'm just kind of catching up on some stuff here, so I can, if there's
Well,
things.
she wanted to have a private talk, but I don't know whether she's still here or not.
No, I'm still here. It's Melissa that wanted to have a private talk. And there was like 11 participants still, so I was just waiting.
Oh, okay.
All right, well, good night, everybody. Thank you.
Okay, thank you.
Thank you, Professor.
You're welcome. Thank you. So we still got a couple left that I see.
Yeah.
Stephanie, are you there? I wonder what power I have to have her not be listening. Stephanie, are you there? Melissa, that's you, right? Lisa?
Yeah, I'm still here. There's like 4 more people, which is a little bit confusing.
Right, I know it. And Stephanie isn't answering, so I don't know that she's actually listening.
Yeah, it's kind of strange.
Andrea, are you there?
Yeah, it's like Andrea and three
Lisa,
more. There's,
Cutting out though.
I heard something.
yeah, it's weird.
I don't know if I can stop this.
My internet is cutting out and I can't see the slide. It's all like morphed.
So we're trying to close the meeting so that Melissa and I can have a private talk.
Okay, bye.
I'm Gus.
Okay, thank you.
I can, before I leave,
Yes,
any time until 1, you said? Like 10 to 1 or something?
10 to 1, yes.
Hello.
Melissa? Yeah.
Oh,
Oh,
no,
Andrea,
that was.
Andrea. 10 to 1. So can these 3 people check out? I don't know if I can stop manage participants. I can do this. I can do this. Okay, so unmute more.
Okay, before I leave, can you hear me?
Yes.
My internet just died again. I can come to you Friday from.
Oh, wait. I did that by accident. Sorry. Unmute. Andrea, speak up again, please. You can come to me when, Friday?
Can you stop? Why am I on hold?
Professor,
Yes.
this is Georgia.
Hi.
Hi, how you doing? I just wanted
Okay, I'm just gonna exit this.
to review the exam number 2, and it doesn't actually tell you which is the correct answers. It just says which ones you got wrong. Is that the way it normally is supposed to be posted?
When it closes, it'll tell you more. I
Oh.
can't have it open. I can't give you the correct answers while it's open.
Exam number 2, you mean?
Yes.
Oh, it's not closed yet?
Right.
Okay, got it. Okay,
Thanks, Georgia.
thank you. Have a good night.
Have a good night, too.
Bye.
Let me stop the recording, by the way. Stop video, stop. Let me stop this recording. How do I do that? Stop recording. I have to stop the share. That's what I have to do. Stop recording.